In this video, we'll implement the Cannon physics engine in BabylonJS. We'll go through the process of enabling scene physics, then create basic physics imposters for a box and a sphere. Imposters are a combination of colliders and rigid bodies that work in a physics environment, and they can be a great way to add basic interactivity to a scene. So let's get started. Okay, so here we are in Visual Studio Code. I have a class opened up called Physics Impostors, and this is similar to what we had in a previous video. So if I take a look at these snippets, I'm using the same prototype demo.ts snippet for this. The only change with that is that I added in a camera and a hemispheric light, so we can actually see something in our scene, but everything else is exactly the same. We're still using the prototype level.gob file. I did make a slight modification to this file, so I removed the ramp at the center point of the world, so we just have everything else that we saw before when we looked at the first-person controller. Okay, so with that said, we're going to take a look at implementing a physics engine. There are different types of engines we can use within BabylonJS. We're going to be using Cannon for this. So I have my terminal opened up. Let's go ahead and import a couple things. I'll close this out. And we're going to import Cannon. So I'm going to say npm I Cannon, and we're also going to be importing the type definitions for this. So add types / Cannon. Okay, so Cannon and add types Cannon. Hit enter. Okay, once that's done importing, make sure that it does show up in your package JSON file. So you should see at types Cannon and Cannon there as well. All right, let's jump back into our physics imposter class. I'll restart my server. Okay, at the very top of this class, it's going to import what we need from Cannon. I need to say import asterisk or star as Cannon from Cannon. Cannon is a physics engine that's built in JavaScript, and we are going to be using this with BabylonJS. It is one of the supported physics engine. Let's go down into our create scene. And in here, we need to enable the physics engine. So we're going to say scene.enable physics. And here we can provide the gravity that we want to use and a physics engine plugin. So for the gravity, this is going to be a vector 3. We're just going to be modifying the y-axis. I'll say new vector 3, 0, and then if you want to use the gravity that you would typically find on Earth, that'd be -9.81. Then 0 for the z-axis. Now for the physics engine plugin, there is a plugin that's available to us with Cannon. We're going to say new Cannon, and you'll see CannonJS plugin. Now in the documentation, it does say you can leave it as such, but I haven't found this to be true. You actually need to provide a couple new things in here. So we need to provide the Cannon injection. So everything that we just imported up here, we need to actually provide that in there. Now the first two options are the use delta for world step. I typically set this to true. And then for the second value, I use value of 10 for the iterations. And then we provide Cannon. Okay, so just like that. Okay, so now we have physics in our scene, so we can start using physics with this. Well, we're going to be creating our things called imposters. Imposters are similar to, say, a collider and a rigid body combined into one. This allows us to have both that rigid object, but also have weight associated with this. What I'm going to do is in here, I'm going to create a separate method solely for controlling the physics of these objects. So I'm going to say create imposters. And this is not going to return anything, so we'll say void for the return type. And what I'm going to do here is I'm just going to create some basic Babylon meshes, and these meshes are going to have imposters that we can create with them. So let's start off with a box. So I'm just creating some basic meshes here, mesh builder.create box. And then for the name, I'm just going to name it box. And we'll keep the options here pretty simple. I'm going to set the size up to say 2. Okay, now in order for us to actually create an imposter, we need to reference the mesh. So box.physics imposter. And we need to create a new instance of a physics imposter class. Now the object here is going to be whatever we want to utilize with this. So in this case, that's going to be the box. Okay, so I want to apply a physics imposter to the box. The second type is kind of cryptic here. It doesn't really tell you a whole lot. But the way we would add this in is by saying physics imposter, capital letters there, dot, and then there you get the options to select different types of imposters. We're going to keep it simple, and we're just going to use the box imposter for this. this is going to be a very primitive looking imposter. Whenever you're working with imposters or colliders in general, you always want to pick something that is very simplistic that will still do the job. This will help with performance overall. Once you start getting into more complex meshes and more complex imposters, your performance is going to drop. Now, this being a box imposter is obviously the most obvious choice. Next, we have our options, and it doesn't really tell you the options in here. So the options we can use are mass, and I'll set that to 0 to start. We also have friction. I can set that to 0 as well. And then we also have restitution. Okay, so all three of these values here can be used as options. So the first one is going to be the mass. This is pretty self-explanatory, but basically this is how heavy this object is. With a mass of 0, this means this object is not going to move at all. So if you want to add in a box imposter for the ground or the walls or something of that sort that's not going to move, using a mass of 0 is what you want to have set up for those objects. Now, friction is going to determine whether or not we can slide around. So if you had say an icy ramp or an icy floor, you may want to increase this or decrease it depending on what you're going for. I'm not going to be using friction for this. I'm just going to remove it altogether. Now, the restitution is a little bit hard to understand in terms of the terminology here. Restitution I like to think of as the bounce factor. With a restitution of 0, this means that if an object collides with this and it also has its own imposter, it may just completely stop once it actually hits it. So if we had a restitution of up to say 1 and the other object also had the same restitution, they're then going to be bouncing off each other. So think of this as the bounce back or the force or whatever you want to call it, the pushback from this object. We need a couple of imposters for this to work. If I have to save this as is, and let's just go and try this out, I'll save this. Let's make sure that we call this up above. And I'll call this right below where we create the environment. So this.create imposters. We are going to see our mesh object, but you'll see that it actually does disappear. So just to see this very clearly, let's go back down here. I don't want this to start at the center point of my world because I won't be able to actually see it. It's actually going to fall through the world. So I'm going to say box.position. And I'm going to go to new vector 3. And I'll set it up to a value of 10 along the y-axis and 0 for the z-axis. Go down into the mass. Let's also bump that up to 1. That way we can actually see it falling. Okay, and there's the box. You can see it just fell through the ground. You can actually look through this and you can see that the box is continuing to fall. Okay, so we have the basic physics set up for the box there, but as you can see, we don't want it to actually fall through the ground. We want it to actually hit the ground, then stop or bounce back, but we don't want it to go through it. Let's take a look at how we can modify this so we actually have a box imposter on the ground as well. Going back into our create imposters method, we're now going to create a floor or the ground object, which will allow us to have the box rest on top of it once it actually collides with it. The process is going to be nearly identical. So we're going to create a ground mesh. Okay, we're going to create a ground. I'll name it ground. And then for the options, I'm going to set the width to, let's go with 20 and the height to 20 as well. We can modify that if need be. Let's also create a physics imposter. So ground.physics imposter. And the physics imposter that's going to work best for the ground is also going to be the box imposter. So I'm going to copy all this right here, and I'll make my modifications as need be. So what are we using this with? Well, we're using it with the ground. And we're still using the box imposter, so we'll leave that as is. The restitution, let's bump this up to a value of 0.5. For the mass, I don't want this to have any kind of weight. I don't want it to actually interact with any other object, so it's not going to be falling. I'm going to set the mass down to 0, which will make it a static object. Okay, so we're setting it up with the ground. It's a box imposter. Mass of 0 makes it static, and the restitution of 0.5 will allow us to create some sort of pushback with this. Now, with the restitution, we need to set this up for the box as well if you really want to see how this works. So let's also bump this up to 0.5 as well. And if we're lucky, we should see it bounce back off the ground. So we have our ground now and our box. Let's jump back and let's see how this works. Okay, there you go. You can see it bounces off the ground. Obviously, having our floor visible like this is not ideal. Whenever we're creating these types of box imposters that are not associated with a specific mesh, let's say we just want to use this floor mesh object as the actual visible part of this, while using this as the collider or the imposter, you then want to turn off the visibility, the rendering of this mesh. So I'm going to bump up the size of this to better match what we have over here. And I also want to disable the rendering of this mesh. This will still allow us to use this as an imposter, but we're no longer going to see the visible parts of it. Let's go back into our code and let's make those modifications. Okay, going back into the create imposters, what we need to do now is modify the width and height of the ground. Let's bump this up to 40 by 40. I think that'll be good enough for now. And for the ground mesh, I don't want to actually see the rendering portion of this. I want to make it invisible while still being able to use the physics imposter. So to do this, I'm going to say ground dot is visible. So is visible is a Boolean true or false. There's also another one known as visibility. That's if you want to modify the opacity of that object. Let's say you want to make it 0.5, 0.75, whatever that may be. This is either true or false. So you're either rendering it or you're not. In this case, I'll set that to false. Okay, and while we're here, let's also bump up the restitution. Let's see if we can really get this to bounce. So I'm going to bump this up a bit further, up to 0.75. You don't want to go too crazy with this because you are going to get a very high bounce with this. So 0.75 here and 0.5 we'll leave for the ground. Visibility has been turned off for the ground. Let's give this a quick look. Okay, and there we go. Now we get a nice little bounce with our cube. It even rotated a little bit. We no longer see the mesh object for the ground, which is great. But as you can see here, we are still using the physics elements of that ground object. Okay, let's add in one more object. We're going to be adding in a sphere, and we're going to be playing around with some of the settings on there as well. Now, we are going to go a little bit faster with this because we already know the process for creating these physics imposters and these meshes. Okay, once again, going back into our create imposters method, let's create one more object. This will be a sphere. This will allow us to use a different type of imposter. So at the bottom of our method, let's create a sphere. We'll say mesh builder.create sphere, and we have different types of spheres we can use. I'm just going to create a basic sphere. We'll name it sphere. And then for the options, I'm just going to provide a diameter. Let's just go with a diameter of 3. And then sphere dot physics imposter, new physics imposter. We'll provide the object that we want to use, which is going to be our sphere. Now for the physics imposter that we're going to use, I want to use something that matches the shape of the object as best as possible. So there is a sphere imposter in here as well. And then for the options for the mass, we'll go up to a value of 1 as well. And a restitution of, let's go with 0.8. Okay, same process as before. We created the mesh object. We created the sphere imposter. We provided the mass of 1 and a restitution of 0.8. Now that combined with the restitution of 0.5 on the ground, we should see this sphere bounce. Now I don't want this to be at the center point of the world. There may be some weird issues if we have intersecting colliders like this. So let's go to move this up above the ground. And let's also make sure that we don't collide with the box, so we're not stuck inside the box either. So we're not going to use the same vector3 values up above. I want to move it over to the left a little bit, maybe along the x-axis. Let's go back down here. Right before we actually create the physics imposter, I'll do that. So sphere.position. This will be a new vector3. And I'll set it equal to, let's go with a -3. And for the y-axis, let's go with maybe 6. And then 0 for the z-axis. And we'll give this a quick try. Okay, there we go. Now we have our two physics objects. You can see they both bounce. One is a little bit bigger, obviously. That is the sphere. They can both interact with the ground. Let's see if we can get these to both collide. So I'm going to place one slightly above the other. Let's also rotate the cube a bit, and let's see this tumble about. Okay, so at the very top of our create imposters, let's modify the rotation of the box just a bit. So box.rotation. This will be a new vector3. And for the x-axis, I'm going to rotate this 45 degrees. I'll say math.pi divided by, let's go with 4. And then 0 and 0 for the other axis. Let's also adjust the position of the sphere. I want these to collide with each other. So I don't want to move this along the x-axis anymore. I'll set that back down to 0. 0, 6, and 0. This is going to be below the box. So the box is at a value of 10. Okay, now this looks a little bit weird. As you can see here, it's perfectly balanced on a sphere somehow. It's not super realistic. Not exactly what I wanted. Let's go ahead and move these out just a bit. So I'll see if I can move the cube off just slightly so it actually rolls off the sphere. Going back to the very top of our create imposters method, let's move this along the z-axis. So I want to move it slightly back. Let's go with the value of 1 along the z-axis. Okay, that looks a lot better overall. Now there is going to be an issue with the sphere. You'll see that it can go through this wall because we have not provided anything that says this is an imposter or checks for any kind of collisions. So it fell off the world there because that's where the end of our ground object, which has an imposter, has ended. Okay, so unless we provide a imposter for all these objects in here, they're not going to interact with our physics environment. They're just visual pieces. Okay, so there you have it, a very simple example of how we can set up a physics engine inside of BabylonJS.